We have a block M which is at rest initially, and then it explodes into two pieces. One of mass one third of the original block, and the other one takes two-thirds of the original block. The question is to find the ratio of the kinetic energy, the Ke, kinetic energy of these two pieces, the piece 1 to piece 2 after explosion. Let's use the concept of momentum conservation to solve this. We have this block M is at rest. So initially the momentum will be zero because momentum is mass times velocity. Since velocity is zero, it's at the initial momentum is zero. The final momentum has to be zero. So let's calculate the momentum of the first piece and the momentum of second piece, add them and equate them to zero. Let's do that to find the velocities, and that can be used to calculate the ratio of kinetic energies. That's going to be the approach. So the momentum of the first piece after explosion is going to be mass times, let's call the velocity of the first piece v1, the second v2. So m by 3 times v1 plus the second piece is 2m by 3 times v2. This has to be 0 because the total momentum initially was 0. So after explosion also it has to be 0. Now this gives, let's simplify this a bit. M by 3 times v1 equals minus 2m by 3 times v2. So the m by 3 goes off and we get v1 equals minus 2v2. Now let's calculate the ratio of the kinetic energies. The kinetic energy of the m by 3 to the kinetic energy of the 2m by 3 block. Kinetic energy we know is half mv square. So half times m by 3 times v1 we know is minus 2v2. So it's minus 2v2 whole square. The whole thing divided by half 2m by 3 times v2 square. Let's keep this as v2 so that it cancels out the v2 in the numerator. So now the half cancels out. M by 3 goes, there is a 2 remaining in the denominator. Let's rewrite this again as 4v2 square when you square the numerator term divided by 2v2 square. The v2 square cancel out and we get 2. This becomes 2, this is 1. So 2:1 is the ratio of the kinetic energy of the lighter block to the heavier block.